Okay, hi everyone. We're the Jakarta EE language server team, and we will be presenting the work that we did during this CANOSP semester. My name is Ananya, and the other members of this team are Daniil, Shaunak, Himanshu, Alvin, and Zijian. Next slide. To give you a quick refresher of what this project is about, the Language Server for Jakarta EE is a project that provides core language support capabilities, such as those of code-complete diagnostics and quick fixes, to enable developers to easily and quickly develop cloud-native Java applications using the Jakarta EE APIs. Next slide. This open source project is hosted under the Eclipse Foundation. This project contains of three main components, and as you can see in the diagram, on the left, the Eclipse JDT LS extension. The Eclipse Java Development Tools Language Server is a Java language-specific implementation of the Language Server Protocol. To the right, we have our LSP for Jakarta Language Server, which is specifically for the Jakarta EE specification. And tying in with both these components is the Eclipse IDE, which is the client that consumes the Jakarta EE language server. Next slide. We worked on this project in a systematic way to ensure maximum efficiency. We split into two groups of three to handle different APIs that were not tackled by the language server at the start of the semester. The first API was Annotations 2.0, and Daniil, Shaunak, and Zijian worked on that. The second one was Jakarta Dependency Injection 2.0. Alvin, Himanshu, and myself worked on that one. We also had weekly Scrum meetings to review our work progress, and everybody got the chance to lead meetings as Scrum Masters. And we also used the GitHub project board and issue tracking system to aid with the same. We also had the opportunity to conduct peer reviews on each other's work, and which was submitted through pull requests on GitHub. And this is just a screenshot of our project board and the different tabs we use to monitor our work progress. Next, Daniil is going to talk about his work relating to a few problems and bugs in the language server.
Yeah, so I'm going to go over some specific issues just to show you what kind of challenges we faced. So the first one had to do with the type hierarchy. So some diagnostics require a class's type hierarchy in order to be precise. So for instance, if a class is annotated with web servlet, then it must extend HTTP servlet. And this is fairly easy to detect if it directly extends it. However, a class could extend HTTP servlet through another file, or maybe through a library class, and we don't have library class information. So the way we solve that is we, next slide, please. We get the type hierarchy for type, well, A, so the demo servlet in that example. Then we get all of its super types to see if type B, so HTTP servlet, is a super type. And there's three cases when we do that. So the first one is that B is a super type, which is great. That means that A certainly extends B. We don't have to have a diagnostic. The second case is that B is not a super type, but the type hierarchy is incomplete, and therefore we don't know if A will extend B. The third case is that B is not a super type, but the type hierarchy is complete, and then we can certainly say that A doesn't extend B, and then we can have a diagnostic in that case. And so this allows us to give warnings in the case that we have an incomplete type hierarchy, and errors in the case that we have certainty of the type hierarchy. And we know that the type hierarchy is incomplete if we do not have the ASC declarations of any of the super types, so meaning the source code. And we can use this type hierarchy for various diagnostics, including pre-destroy and post-destroy. So those require that a method annotated with them only throws checked exceptions. So we could check that each of those exception types extends exception, but does not extend runtime exception. So overall, this type hierarchy solution is pretty useful for many diagnostics. Another issue is the keystroke delay issue. So this is kind of an annoying bug where diagnostics are always one keystroke behind. It's been an issue for over a year. And this was fixed by just waiting for the underlying file resource to catch up. So whenever the user changes the file, it has to be sent over to the language server to be processed. And the problem was that it was being sent, and diagnostics were immediately, or it was analyzed immediately for diagnostics, but the underlying file resource didn't actually update. So we just had to wait for that. So before, if you'd have a diagnostic, you make a change, the diagnostic wouldn't go in until you press the spacebar keystroke. But now immediately you get the proper results. So every single keystroke results in proper updates. And then here's some more just challenges and little things we had to handle for diagnostics. So there's an annotation that requires that a string value follows the ISO 8601 format. There's also an annotation that, well, if it's used on a class or something, then it requires particular attributes to be specified. And this isn't something that you can encode into regular Java annotation constraints. Another thing is that if a method is annotated with a particular annotation, then the spec says that it can't have any parameters or it has to have a certain return type or to not be static. So we had to check all these various things in order to have diagnostics for these annotations.
Okay, so this is the dependency injection 2.0 part. So to give you a little background on the topic. So the use of dependency injection follows a strict set of specifics as highlighted by the Jakarta EE specifications. Developers must adhere to implementing these in their code. The language server for Jakarta EE aims to provide diagnostic and quick fixes abilities to basically fix the dependency injection specifications. So this is how it started for us, and this is how it's going. So previously, whenever a developer was coding, they can only see this error, as you can see in the terminal after running the program. This is a runtime error. But now, with our implementations and specifics, even if there's a mistake, the developer can see it right away that, oh, there's a mistake, and this is the error, and then these are the quick fixes for them to like be more efficient and productive in the code base. Next slide. And these are some of the diagnostics and quick fixes that our team worked on. First was the inject annotation fields cannot be final. Injectable methods cannot be final, static, abstract, or a generic type. Inject annotation cannot be applied to more than one constructor per class. Managed bean class must either have inject constructor or a no argument constructor. Otherwise, the language server will throw an error. Bean class of generic type must have a dependent scope specified. Any parameters that has these annotations such as disposes, observes, and observes async in a bean constructor are shown by the error by the language server. Next slide.
Okay, thanks, Himanshu. I'm Shaunak. I was on part of the team that worked on the annotations part of this, along with Daniil and Zijian. So this is just an overview of like the steps we followed to identify and fix or implement these annotation features. So first we would look at the spec. For example, we have the part of the spec here on the right saying that provider classes must have a public constructor. So, or that's like the gist of it. And then we opened issues based off of that, and then implemented diagnostics, which is either a warning or an error saying that, you know, this is how it should be according to the spec, and then adding quick fixes and then writing tests. So here is an example of this is the provider quick fix that you just saw on the spec earlier. A message will show up with the same like error message, and then you do a quick fix and it will fix all your problems. Okay, yeah, so that's just, then the language server will see the update and then reduce that to a warning. This is what the tests look like. These are integration tests, and they run every time that we work with or open a pull request and work on GitHub, so that just to make sure that things are consistent on every pull request. This first image here asserts diagnostics. And this second image is like for quick fixes, just a sample of what the tests look like. So they check the line number and the character numbers of the diagnostic, and then the message and the severity and the code. And the quick fixes just do a message and the behavior of the quick fix. And yeah, these are Maven JUnit tests. Now I'm going to stop sharing my screen and we'll give it to Alvin for a demo.
Give me a second. All right. So here I have a very simple project that is meant to be run with Open Liberty, which is just a simple framework for microservices. I have a web servlet with this URL, and I created an object that is supposed to be injected called greeting, where I use this object to use its method called greet with a string here. And we take a look at the greeting object class. We have just a simple dependency class that has the method that I mentioned before. So if you can see in my terminal, I have everything running. Everything is perfect, no problems, running at port 9080 in my local host. If you look at my browser, oh, sorry, let me refresh that. You can see everything works as expected with this greeting Bob string. Now, if the developer decided to add a specific constructor, say string greeting with a argument in its constructor, you'd see that there immediately is an error over here. Oh, sorry. Sorry. And then if I, before the diagnosis and quick fixes that we implemented, it used to not throw any errors, and the terminal would give out this unsatisfied dependency error over here. And if you look at the browser, if I refresh this, it also will throw an error like so. So we implemented the diagnosis and quick fix, whereby if you hover on it, it shows the error message, as well as 3 different quick fixes that we can use. So in my case, I would choose this public constructor, and everything looks fine now. I save my terminal. It's now working again, and just to double check, look at the browser, and once again, we have this greeting Bob as expected. So yeah, that's it for my demo.
All right, thank you for that.
My name is Zijian, and I'm in the annotation group with Shaunak and Daniil. So what we learned from this project gave us a lot of hands-on experience in Java development. I remember at the beginning of the September code sprint, some of us spent a lot of time reading about annotations and dependency injection and setting up an Eclipse environment. After a few weeks, we became familiar with reading industry-level code and started to pick up issues and made pull requests on GitHub. We analyzed what kind of role a specific annotation should play, and then through our analysis, we wrote the corresponding diagnostics. And with these diagnostics, we can add a quick fix for our annotation and make our own test. We learned how to use Java techniques such as Maven and JUnit test to test our code. Basically, we have to find out which character to which character in which line of our code. Our diagnostics and quick fix can act on and write our own test cases to test our implementation. At the same time, we also learned how to cooperate to complete different tasks in such a large project. As mentioned, we are divided into 2 groups. We need to analyze other people's code and make use of them in our own issues. So. Yeah, you can continue. Next slide.
Okay, yeah. So what's next for this project? We still have some issues open. We weren't able to completely write all the annotations for like the entire spec. So we have diagnostics for circular inject dependencies, for example, or just other annotations like the resource annotations that we weren't able to finish. Yeah, so once we have completed like basic support for Jakarta EE web profile APIs, and the project will be like closer to its 0.1 release on the Eclipse marketplace. So that's, I think the spec was originally published on around May 2020. So it's been getting closer and closer since then. We just wanted to say thank you to this program for giving us the opportunity to work on open source code and contribute to open source projects, as well as shout out to Kathryn for being a really helpful and patient mentor with being responsive with all of us and giving us help on whatever things we needed during this project. So yeah, any questions?